Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. 11.7 is subnets to meet requirements. This is going to be looking at subnetting to figure out how many addresses. So here we're looking at subnetting private versus public IPv4 address spaces. Again, private addresses are going to use the 10, 172.16 or 192.168 boundaries. And here we can have an internal network using a private address. We can have a DMZ that is either public or private, but using NAT to actually NAT our address space. So we can have an internal private address for our DMZ that is NATed to a public address. Here we have figuring out how many addresses we need, how many subnets we need. Here we're looking at if we're dealing with two private addresses networks, we're going to need two different subnets. But that's the thing is, we need to also understand how many devices per subnet. If we have to have one subnet that is capable of handling 500 hosts, and we need a DMZ that can handle 10 hosts, they're not going to be the same size subnet with host count. So /25 doesn't work here. But again, the number of hosts is what we give to our devices. That's usable hosts. The number of subnets are basically the individual groups that we're going to need. In this example, we're talking about efficient subnetting. Essentially, if we know how many hosts we need, we can group them accordingly. This will allocate, this example, we are looking at 10 host bits. That means we can get 10 subnets with a /26. Problem with the /26 is, does that give us the addresses that we need? And we already know it won't. If we have a /26, we're getting less than 30 hosts per network. So it kind of just depends on how many hosts are we trying to get. How we figure out the host count is essentially we look at the last one position, and that gives us a grouping size. And that actually I'm going to save for a different lecture because we need to here just look at the host count. If we're looking at our host count here, this is going to be total hosts. This is not a /26. This is actually a /22. We get our 1,024 addresses minus the 2 for our usable. So again, here this is going to allocate 10 networks, but each network is not going to be 1,000 hosts. If we need 1,000 hosts, we're going to need a /22. So you have to keep in mind when you're doing the calculations, how many addresses do you need? How many networks do you need? Those two pieces of information allow you to calculate how many networks and how many hosts. We get the /26 because we really do not need that many public addresses. In this example down here, we're dealing in the less than 62 hosts per network. That's that /26 gives us just under 64 usable hosts. So that's why we have 40 public, 25 public, 15 public, 10 public, 30 public. All of them fall underneath that total host count per network. /26 gives us 62 usable hosts per network. We have another lab verifying that you can do this. And this is where we get into the meat of our addressing. That is called Variable Length Subnet Masks, VLSM. VLSM basically means that we can change our subnet mask accordingly. Here we have 4 buildings. They all have the same subnet mask. The hosts between each building have the same subnet mask. Well, this is inefficient. This is wasteful. With VLSM, we can actually modify this so that we don't need to waste so many addresses. Here, we are wasting 28 addresses per network. So we have a lot of waste. What we can do is, between each host, between each building, maybe instead of a /27, we only need 2 usable hosts, we can apply a /30. /30 gives us 2 usable hosts. That means we are wasting addresses. We can also then tighten the different buildings so that we're not wasting addresses again. But in this example, we're looking at just the interconnections between the buildings. Here, again, using VLSM, we're going to subnet the LAN so that we have a little bit better structure. With 25 hosts, with 15 hosts, with 28 hosts, they all fall underneath our 30 usable host range. So all of them would be appropriate because we either have 126 usable hosts. Again, I'm staying in the 4th octet. We have 62, up to 62 usable hosts. We have 30 usable hosts. And underneath 30 usable hosts, we have 14 usable hosts. Then we have 6 usable hosts. Because again, if we're looking at the binary, we have 1, 2, 4, 8, 16, 32, 64, and 128. Again, we're subtracting 2, that gives us our usable count. So 126, 62, 30, 14, 6, and 2. This is our /30, so that's why we get our /30s for these interconnects. For building A, B, C, and D, they are greater than 14 hosts, so that network doesn't work. We've got to be in the network that gives us 30 usable addresses. Yeah, we're still wasting addresses in each group, but our waste is less. So, what is the structure and design aspect of our subnetting? Essentially, a network has to be able to grow. It needs to be able to expand as the network expands. So to develop an IPv4 network, to have an appropriate addressing scheme, you need to know how many subnets there are now and how many may be needed in the future so that we can build on a growth. How many addresses are going to be private, how many addresses are going to be public, and what information is going to be needed. Basically, you can examine the needs of an organization to determine the subnets and the overall host counts. If we're doing this in a structured fashion, we'd be performing a network audit. You'd be looking at network requirements, looking at the entire network, how we're going to organize it, how we're going to group it, how are we going to add DHCP for address assignment to each of the groups, and how many hosts per segment. So we also have to look at how are we going to be doing our addressing. That's typically going to be done through DHCP. But we can do end-user clients using DHCP. We can have servers and peripherals. Maybe these are static addresses. Maybe these are DHCP with reservation addresses in DHCP, so they always get the same address. If we're dealing with servers that are accessible on the internet, maybe we assign them a public IPv4 address, or maybe we assign them a private address statically and we map NATing to them. We have to make sure that we have intermediary management security devices that allow our devices to communicate. All of these have to go into our network planning. We have a lab discussing packet tracer and VLSM design. I've done several videos on VLSM and the importance. If you're going into networking, you need to understand VLSM and how it functions. If you want links to any of those videos, leave a comment and I will get those to you. And that is this chapter in a nutshell. If you have any questions or concerns, please reach out.